as I said before, one of my TAs has been working on getting your evens ready. So here we go. Start grading it as you do. You guys have your correction papers already, true?
Yes.
All right. Tom, Jason, John, Corey, Dylan, Alan, Trina, Noah, Lucy, Brendan, Emily, Kelly. I think the rest of you got them this morning. Is that right?
I got it yesterday. Oh, you took yours later.
I don't think yours is graded yet. I'm sorry, Yuki. Oh no, it's right here. It's right here. I left it. I don't know why. Here you go, Yuki.
I don't know if I copied the ground.
Hey guys, double check really fast. Some of you know in pre-cal sometimes the questions didn't quite match up. I think BC is normally right, but does number 4 make sense for some of you guys?
Yeah.
Yes.
Where's the negative root of it?
Yeah.
I
got it.
I just got the apps.
Do you guys give a graph of the derivative? Is that what it is?
Yeah, they gave it. They gave it.
Like given.
Graph of the derivative?
They showed us. Just give it a graph. I don't know what it is. It's endpoints. I didn't take the endpoints.
Oh, that's what it is.
Is that the upside down triangle? Is that what it is?
Mm-hmm. Oh, no. It's the one that goes down and then up and down.
And then for those of you guys that labeled it, is that the graph of the derivative or the original? Okay, for those of you that labeled it.
I'm pretty sure it's
original.
Oh, I just heard derivative and the original.
It's original.
They just said
find
find
the
extreme values.
All the time is fine. So question, why is negative 3, 0 a local max?
Because if you endpoint.
You have to think closed interval. So if you're looking at this graph, is there another side to consider? No. And what interval did they give you an interval that you're supposed to be considering? Oh, it just gave you a graph?
Negative. Tell you to look at it. And then they
But it didn't show negative 3 to 2 as an interval?
No, but there was labeled like at that point it was negative 3.
So then think about it, if we're talking about continuity on a closed interval, if we're looking at a closed interval, you only have to come to the left endpoint from above, and you only have to come from the right endpoint from below. So that's what they technically say, this is a local max and a local min. We wouldn't call it, on the entire domain, we wouldn't call it relative. We wouldn't even call it local on an entire domain if it was to keep on going. But since they closed the interval and they're telling us to consider only the closed interval, then we're allowed to just look from below and from above, from above and from below, and consider them as a local max and a local min. Yeah, that was awkward, I agree. Number 8 and 14, 14 you need to scroll down a little bit.
Sure.
Number 8 we're okay on them?
Wait, what was 14 asking me again?
14 was that?
Oh, yeah, the time you like.
And they gave you a function, you had to take a derivative? So e to the u times u prime is our derivative. We're supposed to think about critical numbers. How did you guys consider critical numbers of the derivative? Yeah, where it equals 0, but hopefully just, I don't know, it's good practice. Hopefully you guys made it a fraction first, right? To think about numerator, denominator. Okay, but just so you know, in this, pause, in this one, it didn't actually make a difference. Do you guys know why? It can never be 0. So it didn't matter whether it was in the numerator or the denominator. An exponential function on its own can never be 0. It's only going to get smaller and smaller as the exponents get negative. And even when it's to the 0 power, it's still 1. So we, in essence, ignore it. But just remember, in general, whenever you have a negative exponent, that is a denominator. But anyway, your only critical number ended up being at 0, right? And then, as I talked about, the domain has no endpoints, so it's not a closed interval. This can never equal 0, so it has no discontinuities. Wait, what was the original function? E to the negative x squared. Yeah, that has no discontinuities either, because the only denominator is e. So then we had to think about 0. I would have said, but you should have thought of a sign chart, because you're talking about extrema, right? So you should have a sign chart of the original function. 0 would have been your only critical number that you would have considered. If you're thinking about k prime and the behavior of k, if you plug in a -1, that's positive. E to the is always positive, so that's going to be a positive. Then afterwards, I believe that becomes a negative, yeah, times 1 or 2 is a negative over a positive. So then we do have a relative max at 0, and why can we say it's not just a relative, but it's an absolute?
That's the only critical.
This is the entire function, right? Strictly increasing, strictly decreasing. Just by nature of the graph, strictly increasing and strictly decreasing, that must be the absolute max.
For a negative exponent, will there ever be a case where if we don't put in the denominator, we're gonna miss a critical point? Or a critical number?
And if you have a negative in an exponent, you're probably talking about an exponential function. I'm saying probably, but you're usually doing like 2 to the negative x or e to the negative x, or you're usually dealing with like a negative x up there, which will never make a 0, so you probably will be okay. The only time you'll be in trouble, is if you have like an x plus 1 to the negative x. No, even then. No, yeah, x plus 1 to the negative x, that would be a dilemma, because you have x equals -1, but you would have probably found that. The only dilemma is if you called it a horizontal tangent. Like if you identified it as a horizontal tangent, but it was actually in the denominator, it was more like a sharp point, or a vertical tangent line. So that's the only time. If you're looking for horizontal tangents and you don't move it down, then you wouldn't realize that it really wasn't a 0, it was an undefined. I think that's it. And what did I say? No critical points that are not stationary points. What are they saying in that? What are stationary points?
That don't change direction.
Yeah, I think it's just equals 0. I think you're allowed to have a change in direction or a non-change. Stationary just means like you're stopped. Like a stationary bike is one that doesn't move. Does that make sense? So stationary points stopped, the derivative equals 0, and the only critical number was when it equals 0. If the denominator had 1, that would have been a non-stationary point. Does that make sense? Moving on. You guys already checked 20? X cannot equal plus or minus 1. No endpoints, so we have to consider the behavior of the graph. You can check your derivative. Now they go through a whole paragraph. But where could you have found the information for that paragraph? Why am I putting dotted lines at -1 and +1? To remind us that they are vertical asymptotes of the original, hence we can't exist.
Really gross.
It's good.
Good.
They have an aftertaste, not horrible.
It's not crazy.
I'm just kidding. Poisoning me?
I will cry.
We're so entertained right now. She's eating them too, Sophie. Going down together. Alright, so, what'd you guys get for your sign chart? Because you should have, like, how would you have answered this without a sign chart? So what'd you guys get? Plus, hold on, there's 4 different intervals. Plus, plus, plus? Okay, that's right.
No, plus, minus.
Struggle! Okay,
I didn't see that there was an extra zero.
got it. Plus, plus, minus, plus. Nope. Plus, plus, minus, minus. Struggle. Anyway, whew, I have increasing, increasing, decreasing, and decreasing. Now you're lucky on this one, because the only relative extrema was at 0, right? And, wait, why would, is that the absolute max? Why can we not call it an absolute max? This is a vertical asymptote, and if it's increasing, where is it increasing to? And then it comes from -infinity, and then it goes down to negative infinity. Are there any absolute extrema of this graph? But what can we say about 0?
Relative.
Yeah. Now dilemma, what if the function had been different, and what if we had the following? What do you have to be careful of? What if it looks like this? What do you have to be careful of? Yeah. Because I put the dotted lines, then hopefully you guys would realize, but if you didn't start by thinking about the domain of the original function, couldn't you say, oh hey, it's a local min, local max, local min, yay, done. But the dilemma is, if you don't think about the original function, you would say there was a relative min at a vertical asymptote. Is that possible? No. Which is why the very first step to testing or checking extrema is check the domain. Good. Pause. I don't know exactly how the question was worded, but if it says the point, find the point of the local max, remember to the x and the y. If it says the value, you have to include the y value or else they will mark you wrong. Careful. 34, 36, you guys can see them. Can I fit 50? No, I can't. A graph? Why did I have a graph? Was it a piecewise function? It has to be, right? 34, you guys got that you're supposed to answer the y value, right? 34, you were supposed to answer the y value?
Okay, do we need to, oh, we were allowed to use our calculator?
I suppose. I think it's kind of lame, though.
'Cause
That's what I was asking. What they give you? A piecewise function?
No, they give you absolute value. So absolute value of x plus 1, and then that's that 1x of this set.
Plus. Absolute. X minus 3.
I don't know what just happened, I'm so sorry.
That's the function.
Okay. So what'd you guys do?
Derive it, right?
Nothing.
Yeah. So how do you derive absolute value of u?
X over x, x over absolute value of x times x prime.
Oh, sorry. Sorry. Close. I'm too focused on this silly conversation going on up here.
It's an absolute value on the bottom.
It doesn't matter, it doesn't matter.
It could be top or bottom. No, it's good for you guys to know though, because the AP might go ahead and put in a multiple choice like absolute value in the bottom or the top. Now it can't be both, it needs to be only one, but the rule can go either way. It's all about just keeping the sign, about how one of the numerator denominators needs to stay positive, the other one can go negative. How do you find critical numbers?
You do the cross multiplication, yeah, it's the same denominator.
Cross multiplication, you don't want that.
Multiply
You can try.
by x
You
over
can
1
dream.
on one thing and then x over minus 3.
You can think multiplying by x plus 1, x plus 1, x minus 3, I suppose. What are the critical numbers that you're going to get though on the bottom?
1 and 3 and negative 1.
Right? But on the top, aren't you going to get a whole lot of mess?
Yeah. Isn't it just going to be the same thing?
Because you can't really go into the absolute values. Well, the problem is you have like this multiplication plus that multiplication, and you can't combine the like terms. So then the struggle is, negative 1 and 3, are they critical numbers? And the answer is yes. They're technically the only critical numbers, that's true. You can't combine the like terms and figure out any other ones from the numerator. But do you see how the minimum value isn't just at negative 1 or just at 3? It's kind of a mess. But long story short, could you have still found the minimum value even with these critical numbers and plugged in with the, wait, we don't have endpoints, so what could you have done? Sign chart? If you guys didn't know the graph, right? Then you have negative 1, and you have 3. You would have ended up getting, hopefully you would have found a negative, and then that looks like negative 1, sorry. I'm actually looking at this, I think that's the graph of the derivative. Is that the graph of the derivative?
Yeah.
Then the critical numbers would be at 0.
Right. And the critical numbers aren't 0 at like 0 and 1 and 2. Am I wrong? 0,
I think it was the original. I'm pretty sure it's the original.
1.
Because there's two ends at -1, right?
No, at 0, the derivative is 0, you're right. This is the graph of the original.
Yeah.
Because at 0, this is going to be 1, that's going to be -1. At 1, that's going to be, which is 1, and at 2, that's going to be -1. Yeah, oh, it does work. Okay, that's the graph of the original. So you're going to have 0. No, not 0. What is it, 4? Sorry, 4. My bad. But it's still going to be, ooh, this is the graph of the, oh, sorry, derivative. Oh my goodness, I'm so silly. And then that's going to be positive. So I'm going to have decreasing, I'm going to have constant, and I have increasing as far as my f. So even if you had done a sign chart, you would have figured out this weird, like how it stays constant for a while thing. And then you could have gone ahead, and the reason why we can't really see that in the math, guys, is we can't really distribute the x plus 1, the x minus 3 with the x minus 3 without absolute values and the x plus 1 without absolute values. But if you plugged into your sign chart, you would have seen this. Either way, the minimum is maintained this whole interval. So you could have plugged in -1, could have plugged in 3, could have plugged in any of the in-between, and you would have gotten your minimum value of 4. That was a weird one, huh? Yeah. Class. No, it's on the calendar. 36 and 15, I think we're done. Is that it?
Yeah.
Yep.
Wait, what's the one?
B.
We did it yesterday, right?
Yeah.
36, how'd you simplify to make it match? Wait, did you need to simplify? Stick it to the man. No. Why do you have to simplify this one? Make sure the negatives are in the denominators and make, because you need one numerator, one denominator to find our critical numbers. So Alan, this would be one where, I'm not saying by not putting it in the denominator you're in tons of trouble, but without making it in a denominator that we can simplify, you don't see the full picture. Which would be a little different based on, especially with product. All right, you guys got it?
Yes.
Any questions on evens or odds? Lucy?
I had a general question.
Yeah.
When it's finding absolute extrema, when we find the critical numbers, when do we have to use the sign chart for absolute?
Oh, hey, this is good for you guys to answer. I kind of said it yesterday, I did say it yesterday, but it's an important topic to go over. So Lucy's question, say it one more time.
When do we use the sign chart for finding absolute extrema?
What would you guys say?
You don't use it.
She's asking when do you need to, because there were multiple times just now I said you need to do a sign chart.
Remembering max, it was a max.
Okay, when there are discontinuities, when the domain is not all real numbers, discontinuities and what else? And you don't have a closed interval. A totally closed interval. It could be like closed on, like a half closed or a half closed. But wait, why is that true? Why can we not just do a table if we have discontinuities or an open interval or any kind of open interval? I'm looking for something more specific. Why can we not just use a table if we have any sort of open interval or discontinuities? What did I say yesterday?
The sign.
No? It's a forever crime.
It doesn't follow EBT.
EBT. EBT, to be guaranteed maximums and minimums that we can find by testing the only candidates, that all comes back to EBT. So for a continuous function on a closed interval, if either of those two fail, we have to use a sign chart and think about the entire behavior of the graph. Does that make sense? Any other questions from the homework last night? Yeah, I mean.
It said the extrema, but then it also had local ones in the answers. So
Yeah. Our book is good, but it's not necessarily AP. The AP is very particular about when it says find the extrema, it's referring to absolute. In our book, for the most part, I think it's going to say absolute. And so when it says the extrema, it means all of the possible extrema, absolute and relative. So that was awkward in last night. I tried to kind of bring it up a little bit yesterday and saying the extrema, the AP is going to say that's absolute, but I didn't go ahead and clarify. Our book is going to say, hey, find all of them. So I would say it this way. In finding for the AP, the absolute extrema, the extrema, in the process, you should be able to identify the relative as well. But you don't have to answer them, right? But in your sign chart process, you should see them. Our book just says go ahead and write that as part of your answer as to what you saw about the entire behavior. Let's think about that. But thanks, that was actually a really good point. You get where to find it in the drawer, yeah? All right, cool kids, let's go ahead to 5.2. Our goal is to finish it today, so let's see if we can. How many slides do I have? Oops, I went way too fast. Don't stop. Oh, we can do it. Look, guys. We only have 1, 2, 3, 4, 5, and this, and AP multiple choice. Here we go. Yes. I finished all of my grades today. Yeah, go team. Go team. Your new tests are in there as well. Yeah, go team. But I need to actually announce this to all my classes tomorrow. I'm doing it to you guys today. All the teachers on campus got a new way of grading citizenship.
What?
Oh, is that very cool about it? Should I show you the chart?
Yeah, what?
We didn't look at
Okay.
it, but she
So, long story short, I did not, for this one, I gave a lot of grace. But I am going to pull it up like tomorrow or sometime this week and show you guys what the standards are as far as what an O constitutes and an S and an N and a U. Let's just say to get an O or an S, you're supposed to have a positive attitude towards school.
That ain't this class.
In this class, but I'm just saying, some of you, if I was honest, you would have gotten a very different letter than you're used to getting in my class. So, I'm not judging, I want you guys to be real. And no, it's not. I want you to be real, so please don't stop being real just to be like, oh, she's gonna start grading harder. I'm just saying in general, even things that are hard or that we don't like, or when we get to related rates or optimization, you're like, nah. Okay, I understand that, but then at some point, do we have to turn off the bad attitude and be like, let's go ahead and do our best? Okay. So I'm going to show you the chart at some point, and it's going to be in other classes too. I just want to give you guys a heads up. If you get really different letters than you're used to, one of the things for an O and an S is a positive attitude towards school.
What's an N? Or wait,
Not
you.
satisfying.
Yeah, what happens if you're not
I'll show. But long story short, the two things that get you an O or an S are positive outlook towards school and basically being actively involved and participating in class.
What about a U?
And so some of you, either the positive thing is hard or the being actively involved and participating in class is hard. So I'm going to try my best to try to help some of you that are usually quieter. That's not a bad thing. I was quieter in school too. I'm going to try and help you guys too, but just realize in your classes if the teachers are looking at these scales, they might grade you differently than you're expecting. The U, to get that one, you basically have to
Pretty much not do the homework.
like have a totally negative attitude, have no control. I think that means self-control. Have no control as far as like how, and I think you are taking away from other students' experience in the class. So your negativity or your distraction or things like that. That's what a U is. A U is that you're taking away from others and their ability to learn in the class is pretty much what a U is. Yeah.
Why is the school trying to take away genuine attitudes?
I
Why
don't
do they
think
want
they
us to be
necessarily
fake?
are, and I don't think the positive attitude is per se that you love everything you do. That's not likely. But it's, at the end of the day, are you positively, like, trying to have a good attitude about the work that you need to do, or are you constantly negative in your approach to school and things?
But there is a middle ground.
Oh, there is. And that's why I say, I said, for me, I want you guys to be real. So I'm not saying don't, like, respond in a real way. But there is a place to where, even in a job someday, whether or not you like it, you need to try to have a good attitude. Is that kind of make sense?
No, I mean middle ground between you're not happy about it, but you don't have to hate it.
Right, and it doesn't say happy. It just says positive, like in the sense of generally.
It can be apathetic.
Yeah, that's true. I don't think apathetic is necessarily enough to scale you down as long as you have the other characteristics. Does that make sense? Okay, here we go. Corey,
I'm gonna ask you this.
you sure? We'll talk more about it. I just want to let you guys know in case, I don't remember when they come out for you guys, But some teachers might have been very literal, and that's technically what we were instructed to be. I was just letting you know that I tended to kind of do it the way I usually do. As far as O's are to those who are actively involved, who are answering questions, who are not taking away from others. Well, that's still kind of true in the class. S's are those who are good, and they're here, and they're present, and they work. But they don't necessarily actively pursue or actively participate, or I don't get very many N's and U's. I didn't, but now according to the new scale, I might need to. So I'm just saying, not necessarily in this class. There are a few that deserve N's according to the new scale, but
As long as they're all doing yours.
yeah.
Does this affect college at all? Will college see our citizenship
Oh, yeah, do they?
grades?
I mean, they'll see them. They're on their transcripts, I think. But
I haven't looked at mine since I'm
as long as you don't have the low scores, you should be fine.
Okay.
But also think that if a teacher is grading you a certain way, that you might want to reconsider how you're coming across in their class, just for future preparation and jobs, etc. Okay, average. You guys know average, F of B minus F of A all over B minus A, right? That's one way of doing average. That's an average rate. True? But when we're talking about value, hold on, we should know this by now. Value, we've had to work through this with maximum and minimum. What's value? The Y value, right? But in this case, hold on, if this is the average rate, so we need to find a slope in order to get that. If I'm talking about value, wait a minute, maybe I'm not talking about a Y value. Maybe I'm talking about a derivative value? A Y value of a derivative instead of a Y value of an original? And does that go along with what MBT says? Yeah, because MBT says there is a place where the value of the derivative is equal to, bless you, the average rate of the interval, right? And this is MBT for differentiation. What's MBT for integration? Well, we're not necessarily there yet. But if you guys remember, for integration we'd have 1 over b minus a times the integral from a to b of f prime. But we'll get to that when we need it. So, MBT, I just wanted to break it down for you guys. I said it last year, but I think it's different than seeing it, plus you already have some sort of background and foundation in this. So as you see it, literally, mean average value. There is a time, there is a place for a continuous function on a closed interval that's also differentiable on the open interval where there is an x equals c such that the instantaneous rate equals the average rate. What are the other existence theorems? IBT, there must be a y value for a continuous function such that the next value. Rolls, which is just a specific MBT, right? Where f of a happens to equal f of b. EBT, there must exist an absolute max and an absolute min for a continuous function in a closed interval, and NBT.
Which theorem is like connected to MBT?
Yeah. Because Rolls and MBT both say there's guaranteed to be a derivative such that. Just Rolls says, what if f of a equals f of b? Oh, it'll be 0 over 0. So, sorry. What if f of a equals f of b? It'll be 0 over a number which is 0. So it says, Rolls says, okay, if those are the same, then not only do we know what this is, but it will also be 0.
Okay.
At least one place. So, whenever you read an FRQ question, and it says, must there be? Automatically your brain should jump to that small list of 5. Is it IBT? Is it EBT?
MBT.
Is it MBT? Is it Rolls? Wait, is it only 4? IBT, EBT, MBT, Rolls? Oh, just 4.
No, we said,
IBT. I'm making sure. IBT, EBT, MBT, Rolls. Okay. And MBT and Rolls are technically, but you can think of all 4. So you guys don't need it necessarily. I'm dying. Necessarily, no, I'm not.
It's from the
I mean, we all are, but that's okay. Put it back. Graphically, remember from last year, that means that if I have 2 different endpoints between 1 and 4, knowing their y values, which are 1 and 4. Well, the y values don't really matter. IVT looks at the y values and all the y values that need to be hit in between. MVT looks at the slope. What is the slope between? What's the slope of the secant line? What's the average rate? There must be at least one place where the slope of the tangent line will be parallel, will be the same, or there must be at least one place where the instantaneous rate equals the average rate. Okay, so that was just a graphical reminder. So, that's the DVD. Oh wait, why do they fail?
It's not continuous.
What? These continuous? Negatives work, positives work, zeros work. Domain is all real numbers.
Which one was that?
But it's not one.
There are two conditions for MVT. Continuous is one of them.
Differentiable.
Is he or is he not? They say he fails, so we're going to say he fails, but why?
Because oh no, because then when you plug in a number,
Negative,
well you can't
When you
have
plug in
one.
-1, you get a square root of
X.
No, plugging in -1 squared is fine. The domain is all real numbers. Negatives, positives, zeros all work. But if I take a derivative, remember the 1/2 becomes a -1/2. I have a denominator. This does not work at 0. Right?
Yeah.
So is it differentiable? Yes, everywhere but 0. Oh.
But
Fail.
It's not MBTS differential everywhere.
On an open interval, but they didn't even, oh, they did. Everywhere in between, -1 to 1. Remember, it could fail at -1 and 1. Continuous has to be everywhere on the intervals, just as a quick reminder. Closed on continuous, open on differential. Long story short, you could have a sharp point, like at -1 and 1. How about B? What fails?
Not continuous. It's not continuous.
Not continuous, pour K, pour quoi?
Oh, 34 is not continuous. They're going to do one time with 4. Oh, wait, I have it.
It's not continuous at 1, because if you take the limit from below, limit from above, f of, I'm just cheating and not writing all the limits because I got lazy. F of 1 from below is going to be 4, and f of 1 from above is going to be 3, and those don't equal. No, 2.
2.
I swear I heard someone say 3.
It was not.
Oh, it is 2.
Wait. We should sue. I don't know what, the copy that didn't work, the donut holes that slowed me down, I don't know. Okay, good?
It's a complicated thing.
Wait, differentiable, doesn't matter, it failed continuity, right?
Yeah.
Okay. Woo! Whoa! What's coming? Anti-derivatives in the MBT section? Oh, you're welcome. Here we go. You guys thought we were done. Wait, why is it in this section?
MVT can actually help prove 1 is a plus.
Right, you said right, go.
Very good.
Oh wait, we have to have a positive attitude.
Go. Capital F is an antiderivative of little f. If capital F prime is little f. Hey, that's a forever prime.
Whoa.
For all x in the domain of f. Anti-differentiation, the process, the act of finding the antiderivative. I give you two different ones. Let's see if you still know how to integrate. Or antiderivative.
Yes. Is that a 5 or an S? I think
But
it's a 5.
Deriving's a lot easier.
S's would be a lot smaller.
Yeah.
Forget how to do that.
Oh. Get your plus C's, kiddos.
Yeah, kill a baby red panda.
You're a baby red panda.
Thank you, you're so cute. That was a compliment.
You're welcome.
This is just the normal
You're
pre-calc.
just spreading positivity.
Yeah, I did honors pre-calc too. I was thinking, you know, I could have done those in a different class. Alright, wait, it's easier.
So we haven't done AP yet, right? Is that what we're doing? Count how many more pre-calc you need.
So that'd be 1, 2, 6.
Can you see how many ABCs I have? I know this one. Yeah. And then what? Eventually, probably not today. Lauren, yes, I hear you.
This is my test. You said I missed 2 here, but I think I only missed 1 because 17. Or 17. Okay, but I need to do something. I don't know what the right answer is, so I don't know how to make my corrections.
Well, that's what you heard. And you know what I'm saying?
Take from the bottom. Corey asked me tomorrow anytime to answer. Alright, cool kids, what'd you get for the antiderivative number 1?
X squared plus C.
How about number 2?
X to the 5 halves
2x
plus
to the 5 halves.
2x to the 5
2x
halves.
to the 5 halves plus C.
I love that association.
Pause! How do you guys go from 3 halves to 5 halves?
I added 1 and then I divided it.
Multiply by 2.
Add 2 over 2, which would be 5 over 2, and then you also need to multiply by the reciprocal 2/5. And then the 5's cancel. You can also double check by bringing the 5 halves down. The 2's would cancel, 5 would remain, subtract 2 over 2, and you get 3 over 2. So, what is the, just a quick, since we haven't really reviewed it yet, what is the power rule for integration? The integral of x to the n
N plus
dx is x to the,
N plus 1 over N plus 1. N plus
and if you have a fraction, it's going to be times the reciprocal, right? Okay.
Who moved the bad man kills?
I did, because I needed an example, and so I saw all your names, and I was like, oh my goodness. A little crazy, yes, very entertaining. At the very, very end of the day, though, NBT actually helps prove y plus c, but how come? Did anybody figure out how NBT helps?
Because there's a constant, you have to derive, you become 0, and there has to be a constant.
Yeah.
So you guys see the whole, like, there must be a constant. You're like, oh, well, it's in existence, something, right? F prime equals g prime, so I'm going to have 2 different derivatives. There must be a constant c such that, well, how does that work with the average and the instantaneous and all of that stuff? Why is NBT not proven? It makes sense that some sort of existence theorem has to be at play.
Because the derivative of a constant is equal to 0.
So if you're going back to.
Yeah, logically it makes sense, you're right. Because if there's a plus c on one of the other sides, take the derivative of both and they have to match. So we're trying to say that even though we're working from one derivative, there could be different functions. And it could be offset by a c. Question is how NBT proves. That's the last question of today. Why does NBT prove?
Because in the closed interval,
Closed interval.
it is continuous and it's
Well, because if f prime and g prime exist, then yes, we could say continuous and differentiable. Tom and Eason, hi.
There is a value between those, which is C.
Where does the c come from though?
To be plugging one through,
Like f of 0, g of 0?
yeah. C.
Where do you think the C comes from?
Let's see if you guys can figure out how NBT applies and gets that. We could replace f prime of g and I mean f prime of x and g prime of x with f of b minus f of a all over b minus a. And g of b minus g of a all over b minus a.
Which equals a number.
The b minus a's could cancel. But the question is, do both of them have to agree with the c?
Not to infinity.
Maybe we'll peek at that one tomorrow to see why MBT proves. We'll see if homework helps you delve any deeper into that question. Because it is true, it is a statement, but how is it true? Oh, hi. Workspace, here we go. workspace in time? I suppose, because you're gonna be grading it in color pen anyway, right? I was thinking pencil.
everything in pen. It writes nicer.
If we have time, I don't know if we'll have time on this one. We might have to start it today, finish it tomorrow.
How do you grade them?
Yesterday, did you guys actually hear what I said? Said? Yeah,
Yes.
interesting, you should listen.
Roasted. Sit down, kid.
Roasting. I was saying if this was a pop quiz, and I said you need to watch out for mistakes tonight in homework. The if was when we were grading, it wasn't the before. Alright, ready, set. 5.2. 5.2 APMC. Alright, let's see how you do. Hey, look guys, I made it bigger this time. Cool. Thank you. It's not centered, is it? Corey, let me see your test code. Are we stuck? Which one are we stuck on?
I can't see it.
Too small. It's e to the x cubed. No, x to the fifth or x cubed? Minus 6x squared plus 8. Alright, we read it off. It's e to the x cubed minus 6x squared plus 8. Alright, go back to it. You guys ready?
Yep.
D has a discontinuity at 2 for its outside the interval. D is continuous until you take the derivative, then all of a sudden it has, or it's non-differentiable at 0. Alright, so talk about tomorrow as to why you got it wrong, and see if you correct any of our thinking as to what happened. Alright, okay, finish homework for tomorrow, is that your plan? A few anti-derivatives and a few Michael kids, happy fifth period, almost lunch.